I just posted a new entry in my blog, and I titled it Zynq-7000 PCB Round 2 with a question mark about PCIe on the title there. And if I step back, I've got this version 1 of this board that I've been working on maybe almost for a year now. So not quite a year ago, I thought, it might be interesting to see if I could actually build something with a Zynq-7000 part. This is a part I've tinkered around with in the past a little bit with some of the Digilent boards. Enjoyed it. I thought it was a nice little platform to work on. But this seemed like a pretty big step up for me in my ability to design, fabricate, etc. But decided to give it a shot. And here a year later, I've gone through a couple of these boards. This is the same board I went through, some revisions on the computer, just on the design side. But the very first version I ordered, and the only version I've ordered so far, is this 0.06 version, which I'm just calling my 1.0 version that I've been working towards. The first one I populated used a -1 speed part, and then I came in and put in a -3. Everything, has been working well. So, the basics of the board, it's got, the Zynq-7000 itself, and then I've got an HDMI output, SD card, USB host or USB device, support Ethernet, USB-C down here for connection to my PC for USB serial, DC power coming in, some miscellaneous expansion ports that can go to different cards. On one of those cards, I added SPI connections, some LED debug indicators, and then also an audio hardware codec, this little chip down here. And then I've also added a real-time clock. So it's that type of thing I've just been incrementally adding onto this. And this is running Peta Linux, and all seems like it's in pretty good order. So that was the first version, and now I'm asking, what would I do if I was going to make a second version? So what would I come in and change with this or add to this for capability? So I decided to do a little bit of reflecting with that, and I came in and made a list of, well, these are things I would probably want to do something with. So there's some minor issues on the first board. I forgot a couple of pull-ups. I had a couple signals not exactly in the right place, and I've had to do a little bit of bodge wiring. No cutting of the board, so there's no traces or anything I've had to cut. It's just some minor modifications to where some signals were going, just done with movement of resistors and bodge wires. So I would incorporate all that into the design. I did not think much about power sequencing on the first board other than power on sequencing, but not power off sequencing. And maybe I'll put a little bit of energy into doing that more properly on a second board. I think according to the documentation, there's some stuff I should be doing that I'm not doing currently. If I look at this board, and maybe I'll just open another one of these in another window so I can leave the picture up. But I also had a programming header right here, and I intended it to be in the format of Digilent's. They have a little connector standard that they use for programming these. And I've got the right pinouts, except for I used a 2.54 header instead of a 2.0 millimeter header, which means I can't just take the Digilent programmer and plug it directly in. Which not a huge deal, of course, but that would be nice. So maybe I'll add an additional header besides the 2.54 and also have the 2.0 just to give me some flexibility. I would like to have power headers. So like this little I/O card off to the right that I plugged in, this expansion card. On top of it, I have this little hat. This is just a little Raspberry Pi hat for an audio codec. So it's a little audio codec, but it requires a 5-volt power, which I'm not passing through this connector here. This is just signals, grounds, and then 3.3 volt. But to get 5 volt, I actually had to run a wire from the bottom of this board over, and then it connects to a little connector on the right side of this green card. You can't see it in the picture, but there's a little 5 volt run for that. Disconnects easily, so I can disconnect this and remove it, but that's kind of a hassle to run that. It'd be nice if I had some quick connect type of power connectors on the top of this to support that. Other things that I might want to consider is USB. I do support USB coming in through this USB-C connector. I find I don't ever use it. I just use the DC barrel and the USB Of course, USB-C can supply plenty of power, but if I plug into an older USB connector, it might have a half amp limit. And so I'm just going to remove that option and just say power has to come from the DC barrel. Then I won't need these little jumpers down here to select where power comes from. I'm just going to simplify some of that a bit. I have an HDMI output, so I go from the Zynq out through this, just a little chip here that helps me do some voltage leveling and maybe some static suppression, things like that. But that goes out to this HDMI connector that's on the bottom side of the board. And I see a bunch of reference designs that use this ADV7513, so I'm considering adding that to my board. And so that might be an addition that I put on here. We'll see as I dig into that. I do have this little RTC again, this real-time clock that I had added. That I might as well just include it right on the board. It's just a simple little IC, this DS3231 plus a battery, and maybe there's a couple passive components on there, but really not much else. And then the audio codec I mentioned over to the right, it'd be nice to just have this header directly be on the main board, or maybe even just put the actual hardware for this codec right on the board and not even need any type of a header for it. I think I can do better in refining which components I select. I know I've had some questions about, ESR values. What ESR values did I use on my capacitors? Why did I use those? How did I calculate it, etc. And honestly, in the first board here, I didn't put a lot of thought into it. I just purchased a lot of my capacitors based on, what was their capacity from farad capacity, voltage capability, but I didn't look a lot at ESRs. I was probably looking at price, what was the price as I looked at the parts as much as I looked at ESR values. So probably more importantly, I was looking at price over ESRs. But I'll probably do a better job of paying attention to that as I go through the design of a round 2 board. I think I can improve the schematic. And now I do have, if I pull it up here, this schematic is what I've been sharing, and it's not terrible. I don't think. Like if I zoom into this, hopefully, if people grab this, it's readable and it makes sense. But I think I can do better in the schematic side of things. So I might see if I can step that up a little bit and just make it a little bit better. Maybe better, visual, better readability, better documentation in the schematic itself. So we'll see what I can do there. Something else that in hindsight I wished I would have done better when I designed the board was as I was, let me get back to here, as I was choosing components in the schematic side of things. Sometimes I was just putting in placeholders. They're the right size footprints, a standard resistor or something like that. And I was just copying and pasting it, and then I would in the value change the resistor value. That's fine, but then when it comes to bill of materials, that made it trickier. That I had to then go look up what are the specific part numbers I'm going to use for each of the resistors, capacitors, etc. Versus if as I'm building out my schematic, I actually select components inside of, I'm using EasyEDA Pro that are, for example, JLC PCB part numbers, and I use those when I select the component. Now the bill of materials should be fully accurate when I'm done, and I don't have to do any translating from generic to specifics as I order parts. So that'll help me both with the bill of materials and as I order parts. Should make ordering very easy if it's stuff that JLC PCB carries. Headers for I2C and SPI. I've got SPI headers that I added over here, so that would be easy just to include little 4-pin headers or bank of headers for SPI devices. Same with I2C. This real-time clock is using I2C, so I could have that clock on there and expose those signals through a small header to plug in other I2C devices. Plus, I've got other I2C coming off of, instead of the processing system, the PL, the programmable logic side of this device, so I can make one of those headers available too, just to give me some flexibility. More onboard LEDs to use either from the processing system or programmable logic would be nice. I've got one down here that I can use from the, let's see, that was processing system. I have some over here I added into a little header to get me to the programmable logic side of things. But it might be nice to have more LED status indicators that I could use on the board itself. I've been using this one up here kind of to show me a version number. And so as I increment versions, I just rotate through these LEDs. Maybe if I can find a small type of display, it might even be something I could do with a 7-segment or some other type of little display that lets me show that same thing. Again, it's going to come down to how much space do I need, and I might just simply put 3, 4, 5 little LEDs that I can control. I do have a whole bunch of IOs on the PL side of this that I'm not exposing. So I have these expansion connectors, so one to the right, one to the top, and those have been handy. So I can build these inexpensive little cards. I can experiment. I can plug stuff in and work with it. But there's a bunch of pins on this BGA that I'm not using. I just, as I was getting to this part of the board, I'd say I was probably running out of energy to route out. And where would I even route them to? I suppose I could put some headers or other things on this board. But I'm probably going to put a little more time and energy into, can I route out all of the unused programmable logic pins? I don't think I really had much for spare PS pins, and what I did came to this little header here. But I think I right now have lots of unused PL pins that I could have routed out. I just didn't take the time and energy to do it, figuring that these two connectors with all of that I/O was more than I was going to need, which still is the case, but it'd be nice to just route out everything. It just takes time and energy to do that, though. I would also like to include a secondary HDMI and or VGA. So I have this HDMI connector here. It's on the bottom of the board. And in this coming week, I'll be adding a little add-in card to the top here that will give me access to a second HDMI connector. So basically the same circuit I duplicated onto a second HDMI input or output. I'm going to use it as an output to start, but I think I can use it as an input also. And then also a VGA, basically a DAC, a digital to analog conversion to go out to a VGA connector also on that little card. And I'm doing that just because right now I'm experimenting and trying to learn more about generating, graphics and signals. And I've done VGA out of FPGAs before, so that's not a big deal. But HDMI, true HDMI, I have not done, so that might be interesting to play with that. So as I do some of my graphics experimenting with the current board, I'm going to use this little add-on click-in card. Well, it might be nice just to include some of that on a new board. Now the VGA connector seems large compared to everything else I'm working with, so I'll see if I keep that on there or not. And then probably the most notable change that I am digging into right now to see if this is feasible is a PCIe connector. And so I'm probably not going to be able to fit this same footprint of a board. I'm going to have to go with a bigger board, which means it will be more expensive. This was an 8-layer board, so I'll have to see what I end up with there. But I'd like to put a full-size PCIe slot on there and be able to plug in a Gen 2 by 4 video card. Or maybe if I get really maybe aggressive on my goal, I could go with a by 8 card. But maybe just a Gen 2 PCIe by 4 card might be nice to see. Could I get that to work from Petalinux? So again, that's a pretty lofty goal, but so was my goal to build this first board in the first place. So I don't mind taking on lofty goals if it's feasible, and that's what I'm reading up on right now or doing some research on. And any input from any of you, of course, is very much appreciated. Looking at that, though, I think the PCI means I need a different, chip. I can't use this 7020 that I've been using. And I say that because there is this in the documentation for the Zynq-7000. And it shows which of these support, from a hardware perspective, PCI Express. And I don't think even with a soft core, there is a soft core to do PCI Express on the part that I have today, the 7020. From what I'm reading is you got to get one of these that has the hardware support for PCI Express because of the transceivers, I believe. That could be wrong, but as I look at this table, though, I can see here's the 7020, and when I look at PCI Express, it's just gray. That tells me, okay, it doesn't support it. So then I need to pick one of these other ICs, one of the other parts in the Zynq family, if I want to do PCI Express. So if I look at this table, I can go down to a 7012, which that seems like too much of a drop from where I am at a 7020. The 7015 looks like it would give me the PCI Express, but generally lower the capabilities. I probably wouldn't notice that with what I'm doing with it so far, but that is a step down overall, but then adds in PCIe. Or I could step up to a 30, a 35, a 45, or a 100. And so I thought, well, what is it? What are pros and cons of some of those? So I put a little bit of thought into that. And where I'm at right now is I'm leaning towards a dash 30 part. And so that dash 30 would give me my PCI Express, and it would be a step up in everything. So in how many programmable logic cells, it'd give me more of that, more LUTs, more flip-flops, more block RAM, more DSP slices, more performance of those DSPs, and again, the Gen 2 by 4 PCIe support. Now, ideally, I look at all these and I say, okay, these top two are really expensive. I looked up, prices, and this is LCSC and probably still very good prices compared to other things out there, but they're still quite expensive. Those top two, 160 or 252 respectively for these two parts. So I'm going to maybe rule those out and just say, okay, that's outside of my budget. And primarily because I'm, maybe afraid that I'm going to go out and put a $250 part on here and do it incorrectly, or have a board that has issues and end up wasting $250 every time I make a bad run of that. So that's a little bit too rich for my blood. To come in here with a part like my current part is this 20. Those parts are in the same ballpark here. This $20-some USD, US dollars. And if I destroy one of those, it's not the end of the world. But if I destroy a $250 part, that would make me pretty sad. But if I step up to a dash 30, which is what I'm leaning towards right now, that dash 30 again is a step up in all around capability, including PCIe. My secondary thought is to step up to a dash 35, and then my third option would be to actually step down to the 15. And maybe the benefit of the 15 is it's closest to my current design. It's maybe one more. It's a 485 package instead of 484. So it should be pretty similar as far as routing, soldering, all of that. Really, I'd just be adding PCIe 4. That'd be the part. Could I get that to work or not? Versus if I step up to this dash 30, it's a 676 ball package. And if I step up to a 35, it's a 900. So that's, double the number of pins of what I'm working with today. So I have concern with that. Now that might be a good challenge, but maybe this 676 is more of a compromise. It's a step up, but not all the way to 900. And let me just go pull up the data sheet, and I'll pull that over here. And in the data sheet, again, I can get down to this table that I was looking at over here. I can scroll up and I can see that the 20 and the 15 use the same, basically, processor core, along with the 30 and 35. It's all the same processor, this dual core ARM Cortex A9, maybe some different speed options. So right now I'm running the dash 3, which is an 866 on the Z020 part. If I went to the 30 or the 35, I could go faster if I could find an affordable dash 3 part. What I've listed in this table over here are all dash 2s, and that's based on availability and pricing. I did not see 3s, or they were crazy expensive, well beyond the numbers that you see here on the screen and beyond what I'd want to spend. Everything else, though, is the same there, and then I get down to here, that table we were looking at, but then they have package information. So I've been working with a 484, this one right here. So that is a 19 by 19 millimeter. It's a 0.8 millimeter pitch. If I went to the 015 part, that uses this 485. So it's a CLG 485. So it's still a 19 by 19, 0.8. So that's pretty much the same physical package, probably the same routing challenges I would have. So, I'm used to that at this point on that part. If I step up to this one, it is a 676. So then I have to keep coming down here and I have to find my 676. And there's two different ones. One of them is this FFG. So that's right here. And it's now a 27 by 27 instead of a 19 by 19. So it's physically larger. And kind of on the nice side, even though it is a lot more pins, it is a 1 millimeter pitch. So my assumption is there that might give me some more flexibility in routing. Can I route two traces between a pair of balls on the BGA? I'll have to get in there and check if that's something I can do. My initial assumption is yes, but that could be wrong. But then I can look at what's down here, and this does show that it has a faster transceiver speed than the FBG 676, but this is the one I did find on LCSC, so 2FFG, so that would be this part here. Now, if I go all the way up to the 35, it's now this 900 part, so that's the next one over, so it's a 31 by 31, 1 millimeter pitch. So that's just a lot. And my comment earlier about routing out everything, I don't know, we'd have to see what this all looks like with that large of a package. And I assume some of those, are powers and grounds and this and that. And I can look at IOs, and if I go from, where I'm at up here, it's 128 plus 200. And I get down here and I've got, let's see, 128 plus 16 plus 212 plus 150. So there's a lot more IO there, and I don't know enough about, let's see, before I was using this HR. So high range IO, there's also this high performance IO. So clearly I've not worked with those before because my part currently doesn't have any of those, but now I would get to maybe try some of that out. But that's, 150 IOs that I could potentially route out. Where and how I would route those out, I have, no idea. Again, unless the board was significantly larger. But that's all stuff I can dig into and see what I can learn. So short version is I'm currently on the 20, and my best option right now is to go to a 30. And I think that's probably what I'm going to do. But I'm curious, for any of you that have worked with, a bunch of these different parts, or if you look at this and have, a suggestion or a concern like, wow, going to a 900 is a major step, or it's not such a major step, or any concerns if I step down to the 15. If anybody has thoughts on that, I definitely would love to hear your thoughts. And then, of course, the board, as I get on there, I'll have to have, whether it's a mini PCIe or a regular size PCIe. I think what I'm leaning towards is a regular size PCIe connector, and then I'll use, like a riser cable that then actually moves it over to a separate side where the GPU would actually be, versus plugging the GPU directly into this card. And I'll have to find an older GPU that's not, one of these modern power-hungry ones. But that also, and I didn't include that on here, that means I'm also going to have 12 volt power in the system, whether I get that separately, or I bring that into this board, or I use an ATX power supply. That's something I would have to figure out as I get into this. ATX power connectors are fairly large, but maybe that's what I do, is I end up doing that, or just simply having a separate little circuit that does my 12 volts. I don't know. I'll have to look into that and research that a bit. And I'll have to add up all the power. What is the power of a reasonable video card that is an older, PCI Gen 2 by 4 card? What do I need to power that? I'm going to want to find a card that can be powered through the PCI slot, ideally, I think. But I need to put more thought into that. Maybe an external power connector is a good thing in this type of a setup. And the goal of all this would be, could I get PCIe working with a GPU in it and have that GPU recognized and working inside of Linux? I know Linux is kind of going into support or not recommended. I'm just doing this as hobby stuff. So for me, it works as well as probably anything else I'm going to find for now. But maybe in time, I'm going to have to switch away from that and find something better, especially if I want to do a PCIe video card. But it seems like Petalinux supports PCIe, and then it's just, can I get a card with drivers that will work inside of Petalinux, basically. So that's all I got for now. I'm definitely looking for feedback if anybody has thoughts, questions, suggestions. I'm going to probably take my time working through this. This could take me another year, I suppose, by the time I get in and through this to have something that is functional. Maybe it'll go faster. I learned a lot as I built this board, so those concepts should all come through. PCIe is brand new. I know it has its challenges, so that's going to be something that's going to take me some time. And I know just building an updated PCB and all the routing, that took a lot of time on round one. So I imagine it's going to take as much more time this time as I go through it, especially if it's a larger board and has more components on it. But if I do move forward, this might be another video series, just a new one that is round 2 of my Zynq-7000 PCB build. Thanks for everybody that follows and contributes commentary and suggestions. I definitely have always appreciated that and will continue to do so. Thank you very much.